Hi, can you hear me? Nice, that's what it's all about. Yeah, welcome to my talk. I will talk about hearing aids and what the state of the art is. There will be a little hacking, but not my own. Yeah, since I know that there are some people interested in my talk that cannot hear very well or not at all, so I will publish slides that have very detailed speaker notes so that you can read it afterwards if you missed anything. I hope there will be a recording available, and if it's possible to add subtitles, I will do those. Okay, first a few words about me. I'm a software engineer. I'm based in Munich. Some people might know me from my time in Cologne as well. I'm more a software geek than a hardware hacker, so all this is also new to me. From university, I have a background in data mining and signal processing. I worked in the medical industry for a while, but that had nothing to do with hearing aids. Also, my current job has nothing to do with hearing aids, so this is really just my personal project. I'm hearing impaired for about 3.5 years, so this is when I started to dig into the topic. And, well, yeah, this is what I will talk about. Since I haven't seen many talks about audiology here at the Hacking Congress, I will start with a short introduction and the process of how you get hearing aids, actually. Then what are the current hearing aid models and what can they actually do? Some words about the peripheral hardware. There's quite a lot of it outside. And yeah, some hacking. And another point is self-tuning. That are people that tune their own hearing aids, although they are not audiologists. Yeah. So this is an audiogram. This is a result of a hearing test that you usually do at ENT doctors. The x-axis shows the frequency in kilohertz, and the y-axis the loudness, level of volume. The silence is at the top, the really loud sounds at the bottom. And the green line you see here is that result of a normal hearing person. And this is obtained by the audiologist or the doctor plays sounds in the different frequencies, starts at a very low volume, and as soon as you hear it, you hit a buzzer or say yes, and then they create this curve. So the blue curve is a typical curve of a hearing impaired person. So what you can see here that at the low frequencies, the hearing is quite well. That's very typical. The hearing starts to get worse in the high frequencies. And bear in mind that the decibel scale is actually logarithmic. So if you have a hearing loss of 60 decibel, it's 1 million more than 10 decibel. So it's not linear. Another thing that gets measured at the audiogram is actually the maximum that you can hear or that you can stand hearing. So the audiologist raises the volume more and more, and you have to say yes until it hurts. So what you see here is the red curve. It's a level of discomfort. And also a typical thing is that it raises exactly at the areas where the hearing goes bad. This is a very complicated thing for tuning hearing aids because they cannot just amplify everything. Because you would hurt people very soon as you get below the red line. Another thing is the area where speech takes place. This is called speech banana, actually, that's a technical term for it. It varies, of course, according to the language and the speaker. For example, female speakers have a slightly different curve than male speakers. And this is the area where hearing aids target, because they are used to make you understand speech again, so they focus on this area actually. And you can see the blue line here, so half of the banana is actually cut, and this is the high frequencies, which in speech are the consonants like S and F, for example. The vowels are usually understood quite well. To give you an impression how I hear, I made a sample. Check. So there's a song called Sad Robot from Phonak. It's a nice band which makes music with a Game Boy and a guitar. And the original has really nice high frequencies at the beginning. This is why I use it for testing. And later there's also some singing. So this is the original. And now I'm going to play my version. So with less high frequencies and a tinnitus as well. There's actually a website where you can download tinnitus sounds. And it says that you should actually turn down the volume when you start broadcasting that because it can hurt audio equipment. So I hope I don't destroy anything. So I will turn it down first and slightly increase it. So this is not a feedback loop, it's the tinnitus, and without the high frequencies, this is how it, how it is. So it's really hard to actually hear the high frequencies. Yeah, so this is just an impression of what hearing aids have to work with. Getting hearing aids is mostly, I like to compare it to getting glasses. So one day you wake up and everything is really blurry and you decide, well, this is probably not so good. I should go to a doctor, and then you go to a doctor, he makes some tests, then he sends you to an optometrist, he makes some more tests, then you choose a model for your glasses, and the optometrist orders the glasses and puts them into the frame, and then you're happy seeing nerds. And then you can see ponies. Getting hearing aids, unfortunately, is not that easy. So one day you realize you cannot hear very well anymore. You go to a doctor, he makes some tests, he sends you to an audiologist, he makes some more tests. You choose from the shop of the audiologist some hearing aid. And then the audiologist has to adjust the hearing aids according to your audiogram. And then it doesn't stop. So then actually the work starts. You have to go through all the difficult hearing situations to test if it works with that tuned hearing aid. So you drive a car, you listen to music or other people in the car, you try to have someone whisper something in your ear, you listen to the TV, or you go to a party where a lot of people are talking to each other and you have to make out the person that's talking directly to you. Or you listen to a talk like that where the speaker is actually quite far away from your hearing aids. And if you have done all that, you go back to the audiologist and you have to tell him why it doesn't work or in what situations it doesn't really work. And then he does some changes in the parameters, and then you have to do that again. And sometimes you switch to a different hearing aid as well. So this whole process, these iterations, it takes weeks or months until you have something that is actually fitting to your ears. And after that, you're sort of happy. Actually, I haven't met a person that has hearing aids that actually compensate for the hearing loss completely. So whenever you are done with that, you're usually just stopping because you don't want to spend any more time on that. And it works well enough. Compared to glasses, this is actually a lot more effort and a lot more frustrating. Another thing is that hearing aids are really expensive. A good hearing aid starts at like 1,500 up to 3,000. And I only have the numbers for the German health system. The normal German insurance pays 500. So there's a lot of money you have to pay for yourself. Yeah, hearing aid models and their features. There are roughly 3 types. In-ear hearing aids that go completely into the ear canal. A more common one is behind-ear hearing aids. They are for mediocre to severe hearing losses. The main part is behind the ear. And another special thing are cochlear implants, where parts of it are implanted into the head and some is attached from the outside. I will mostly talk about the behind ear hearing aids because that's what I have, and yeah, where is a lot of variety on the market. Yeah, hearing aids got pretty invisible. These are pictures of me wearing my hearing aid and not wearing it, so except for this little wire on the right side, you cannot really see it. Most people that don't have hearing aids find this an advantage. People who have a hearing aid actually are not that sure about it, because sometimes when you have to ask someone to repeat a sentence, if they know you're wearing hearing aid, they think, okay, she didn't get it because of the acoustics. And if they don't see it, they think, yeah, she didn't get it because she was stupid. So it's really not that obvious, and sometimes it just helps that people see that you have a handicap. Yeah, they also got pretty small. This is an example of my hearing aids with a 50-cent piece to have an impression of the size. And you can see that actually half of it is used by the battery compartment. Out of curiosity, I took my hearing aids apart, and of course. You can see they have like shells which you can take off, which is like for mobile phones, you can switch the color and choose a different one. And the body still, I know this picture is not really good, there's still a lot of plastic around it. And the white part, there's two microphones, the signal processor and antenna that's used for peripheral hardware. I will come to that. And the speaker is actually at the part that goes into the ear. And what you can also see here, that the part that goes into the ear has also like holes where the natural sound can still come to the ear. So if you still hear like low frequencies, then they can you can perceive them naturally, and only the hearing aids only adds what you cannot hear. This is called open hearing aid, and it has the advantage that you still hear natural sounds, which is really nice if you like, if you're really sort of an audiophile person that likes to listen to music. And so the first thing you do is actually choose that one. Yes, in the last, I think in the last 2 centuries, hearing aids got digital, and with that, they come with a lot of new features that you couldn't do with analog hearing aids. And right now they're standard in most first world countries. And yeah, the most important thing is that they can analyze the situation and react to it instantly. Since they have signal processing in it, much more sophisticated than analog hearing aids did. Coming back to the audiogram. This is actually a feature that can also be done by analog hearing aids. I don't know in what extent actually. So if you have a look at this audiogram and only consider one frequency band, like for 4 kilohertz, here the hearing loss is between 60 and 90 decibels. Over 90 decibels it gets too loud. And the input of the environment still has the whole range. So the hearing aid has to map 0 to 130 decibel to this small area between 60 and 90. It cannot just amplify everything because that will hurt. And this is called compression. This should not be mistaken with compression in audio files like MP3 or something. It's a little bit different. And if you have a look at the software that is used to adjust hearing aids, it looks like that. You have the mouse here. This controls here at the amplification, and this here reduces the maximum level. So my hearing aids can at maximum do 108 decibel, and if you have like -12, you just subtract it from that. This has a problem that if you compress it, the volume gets like increased and decreased all the time, and this can actually make it harder to understand speech because the hearing aid is adjusting all the time. And so to avoid that, they don't compress every time. So the first area here is linearly amplified, and only after a certain level they start compressing, and this is called knee point. So that they usually try to avoid compressing the speech signal and only something above that. In the hearing adjusting software, it looks like that. This is actually an example only from Siemens. Every brand has their own adjusting software, or tuning software, so this is just an example. So here you have the knee point in the first row and the factor by what it is compressed. And this is actually, the third row is a factor regarding how fast it should react. So syl means syllable, so within one syllable it's adjusted to the right volume. Okay. The problem is, what do you do when your hearing loss is so bad that the red and the blue curve actually meet each other, or the blue curve goes all the way down? And this is actually a problem because then you cannot do compression anymore, at least not in the original sense. So you have this is a simplified audiogram. This is the area that is dead. So instead of compressing in one frequency band, you compress the frequencies. So you reserve a part of the still alive hearing frequencies and map it there. This is called frequency compression, and it works only if you have closed hearing aids, meaning those where you cannot hear natural sound anymore, where the ear canal is really blocked by the hearing aid, because otherwise it would be really confusing. And this is actually offered by only one brand right now, by a company called Phonak. And it's actually quite hard to get used to that. The brain has to adjust to that for a very long time. What I heard, I don't have this. But still, it's interesting that they try to do it like that. A very common problem with hearing aids is feedback loops. Especially if you have open hearing aids, then it can happen that the hearing aid captures its own sound and amplifies it a lot. This is the squeaking, what you get when you get too close to them. And this is really annoying. It happens every time something gets close to your ear. So it's just like, it can simply be hair wearing open, or you put on a hat, or you hold a telephone handle next to your ear, or you just want to lie down on the sofa. Or especially when you hug someone, you start squeaking, like you give bionic feedback. This is really, really annoying. And what the hearing aids do, they try to detect feedback loops. So they look for clear sinus signals, and when they detect one, they send an unhearable flag. I detected one, and then the affected frequencies get damped so that until it doesn't squeak anymore. They can adapt in real time, so it actually works really fast, but it's still hearable. So problems with that is that music contains clear sinus signals, and those get then damped, which make your music experience a lot worse. And also the damped frequencies can be in the speech banana, and then that means whenever you put on a hat, then you get a feedback loop, then the frequencies get damped, and then you cannot understand anyone anymore. Analog hearing aids did not have a measure against that, so this is something that is clearly new with the digital hearing aids. The screenshot here is also taken from the tuning software. When you have tuned your hearing aid, you can make a feedback loop test where it plays a lot of different sounds and tries if it detects the feedback loop, and then it reduces the maximum power of the output of your hearing aid. That means you spend hours tuning your hearing aid, and then everything gets reduced by that. A very common problem for people with hearing impairment is the cochlear party problem. This is when you're in an acoustic setting where a lot of people are talking and you have some background noise, and then someone is talking to you and you have really problems to figure out the person that is talking to you. And there are several factors in that, and hearing aids react to that in several ways. So first of all, directional hearing is impaired when you have a hearing impairment. The human ear uses the 2 ears and the brain to locate the sound, and we use the pinna, that is actually the outer part of the ear, Ohrmuschel in German. If you have behind-ear hearing aids, of course, most of the microphones and everything else is behind the ear, so you cannot use the pinna. You have to simulate that in a different way. And this is why both hearing aids have 2 microphones. So you have 4 microphones in total when you have like hearing impairment on both ears. And they, this way they can detect if the sound comes from front or back. And they talk to each other, so they can also detect if the source the source of the signal is right or left to you. Additionally, they try to recognize the situation and automatically focus on the person that is talking to you, and also to reduce the background noise in general. The in-ear hearing aids I showed before, they of course still can use the features of the pinna. This is also a screenshot from the tuning software. You can actually test your directional hearing in real time, so you can wear your hearing aids connected to the software, and then you can do something like that and see if it's recognized correctly. It works more or less in a silent room, but yeah, not in a cocktail party. Yeah, generally it's really hard to extract foreground from background noise, because foreground noise has all the high frequencies and background noise doesn't. And if you don't hear high frequencies at all, everything is like one blob of sound for you. Hearing aids help with that because they mostly focus on high frequencies, and they have filters to filter out the background signal. But actually that doesn't really help so much, because those situations, recognitions, they tend to fail as well. So sometimes exactly the person that is talking to you gets faded out because it's considered as noise. But sometimes they also work pretty well. I mean, it's also, coincidence. Sometimes you're in a setting which has exactly the situation that the hearing aid can work well with. So sometimes you are here with a hearing person actually, and then you hear him quite well, and then you start talking in a normal voice because you can actually understand everything, and then the hearing person is asking you to repeat a sentence. This is really weird sometimes. The tuning software for hearing aids also has a Realtime Monitor where you can see some parameters. So you wear hearing aids and then, for example, listen to music, and then you can see here the dark areas are where the hearing aid actually started to work. Below that it doesn't need to amplify, and the gray thing here is the speech banana. So you see that it's optimized in a way that it starts amplifying in the speech banana. It also has this situation recognition in different settings, and one of it is music actually. I tried with different types of music. Actually, if you like heavy metal, you will never see music here. It's usually noise. A problem with hearing aids is humidity, actually. So most hearing aids are not waterproof. That doesn't sound so bad, but actually a lot of things are related to that. So that means no swimming with friends, no pool parties, no water sports where you have to talk to someone. Sweat is a problem, especially for people who do a lot of sports. No audiobooks in the bathtub, no heavy rain. So if you go to an open air concert and it starts raining, you will really have to take care of that. Also, just like wet hair, when you go out of the shower, you have to wait until your hair is dry until you can put your hearing aids in again. A very recent development is that Phonak also offers hearing aids that are waterproof or water resistant. They claim that you can hold it underwater for 30 minutes and then there will be no irreparable damage. I'm not really sure what that means, so I guess you probably have to try it. Or if you have to give it into repair for weeks until you get it back. Oh yeah, by the way, you don't have a spare hearing aid, so whenever your hearing aids break, you have to go to an audiologist, and you get a spare hearing aids, which is like when you drive a Porsche, you get a tractor. And also, audiologists have opening hours for the elderly, so if your hearing aids break on Friday night, you have to wait until Monday until you actually can hear again. Yeah, those were the important features of hearing aids, but there is some peripheral hardware that I would like to present. So there are different interfaces for which you can use to plug into your hearing aids. So the oldest one is the direct audio input, which is just a cable. So it looks like that, and it's usually connected to the hearing aid with some sort of shoe, which looks like that. And yeah, it has the pros and cons of cables. Of course, you feel like being on the leash, but you also have no interference with other like wireless stuff. It's usually used to plug something else in, for example, FM or Bluetooth adapters. And yeah, I mean, this is pretty old technology, but it's still around. Although for really small ones, the plug is actually too big, so they leave it out there. Another very common technology is FM systems. You can buy those from several vendors. You have like receivers and transmitters. They have different setups, like for a meeting that you can put a microphone in the meeting table and hear all the participants talk, or for lecture halls like that you can connect the microphone to the transmitter and listen to it. There are some standards, but most receivers and transmitters don't work with others from other companies, but at least if you plug them into with this direct audio input, you can choose a receiver, a FM system from a different vendor than from your hearing aids. The sound quality is said to be quite good. I actually could never try it, but I heard that actually in schools, hearing impaired students listen to music while actually they should listen to the teacher. And teachers call the audiologists and ask, like, could you make that stop? I mean, they don't listen to what I'm saying. A really common problem for hearing impairment is calling on the phone. The problem is, first of all, most people do lip reading, so they don't rely only on the audio input. We use the visuals as well. And of course, you don't have that on a regular telephone. And also for technical reasons, the frequency range of the phone line is reduced. In Germany, it's like 300 hertz to 3.4 kilohertz. That's the blue box in this audiogram. Also, the background noise that you have in the room where you are talking on the phone does have the full range, so you get actually background noise in a better quality than the signal from your person that you're talking to. Then often the signal is altered and unnatural. Sometimes you have bad reception, and also you hear it only in one ear if you just use a usual telephone. And if you hold it to your ear, you get a feedback loop. So a lot of things make it really annoying to talk on the phone, and there are some technical solutions for that. The most old one is the Telecoil or T-coil, and it's connected, and the source is connected to an induction loop, and you take off the electromagnetics and this is from the Telecoil. It's there in the picture, a really small antenna, and there are different ways. Different setups for the induction loop. So there are adapters that have the induction loop actually used to hang it around your neck, or there are induction loops installed in lecture halls like this. I don't know if there's one here. It's widely used in Europe, especially in Scandinavia. They even have laws where like every public building has to have one, or at least public lecture halls. You have some pros and cons, of course. You have interference. When you move inside the induction loop, the level of volume changes. So it's nothing where you should like dance or something, but if you sit still in the theater or something, it works. Installing an induction loop in Electro is quite expensive, but there are actually DIY kits available. It's quite common that people build their own ones. Telephones also have an induction loop, even very new ones. So all telephones which are called hearing aid compatible, they have an induction loop that can be used with the Telecoil, even like the new iPhone, for example. And then there's Bluetooth. Hearing aids, there are right now no hearing aids that can do Bluetooth directly, because mostly of the batteries. Usually, hearing aid batteries last like 1 week to 10 days, but with Bluetooth, I think they will only last a couple of hours. Although there are no Bluetooth-enabled hearing aids on the market right now, I've heard that they are working on that. Siemens is located in Erlangen, which is not that far from Munich, so I have heard about people who would like test prototypes. Right now, if you have to use a Bluetooth adapter to use your hearing aids as headset, and there's different version of it. So this is an example of Phonak. They built a really nice thing. This piece, you hang it around your neck, and the ribbon is actually the induction loop that is used with the Telecoil. And to this gadget, you can connect several things. It has direct audio input, which you can use to plug in an FM system. It also has aux in that you can like directly plug in your MP3 player, and it has Bluetooth. It actually also has a warning to combine this with pacemakers. And I have a friend who has a pacemaker and this thing. He just ignored the warning, but I think this is luckily he's still alive. I think this is a good example for what we are heading in the future. I mean, we will get more and more cyborgs, and I doubt that every hearing aid vendor is trying the adapters with every pacemaker there is. So we will get a lot of compatibility problems in the future. And I mean, if this really works, it might be an option to kill people really, really silently, remotely. I mean, you have to think of that. Yeah. Siemens' solution was, of course, not to use any of the existing standards, just build something new. So they built something called Siemens Tek, and it talks Bluetooth to the phone or to whatever you connect it to, and some wireless near-field protocol to the hearing aids. So the hearing aids also have a small antenna in it, which looks kind of like a telecoil, but it is not, and it is not compatible to anything the telecoil is compatible to. So you can only use it with this. It has a signal around 3.3 megahertz. You can see it on the picture. I tried that. And it's compatible with every Bluetooth speaking device, in theory. And practically, you have to check it with everything. So whenever I get a phone at work or whatever, I have to check if it actually works. So of course, it works best with Siemens mobile phones, but you can imagine how old they are. And yeah, they also are supposed to work with landline phones, but on their websites, they say only two. I think it was only 2 Siemens mobile landline phones, of course. And other than that, they don't guarantee that it works. It comes with an additional transmitter that is connected, that you can connect to a source that is more far away. The Tek itself has a range of like 1 meter. So if you want to have an in-flight screen TV, like, I don't know, 5 meters away from you, you use the transmitter. This thing costs about 400 euros for just turning one wireless protocol into the other. And no insurance is going to pay for that. So you have to pay for this on your own. If you have like a generous employer, you might get some for it, but yeah. They also released a new version of it. This is on the right side here. It's called Minitek, and it has actually less features than the old one because they removed the display. And they still want €400 for that, and you don't get a discount if you bought the old one. Well, but I guess that's marketing. This is the setup with the transmitter, so you connect it to the computer and you wear the tag around your head. It also has some buttons for the different programs. So hearing aids have different programs that you can change manually, so that you have one for like listening to music, or one for your living room, and one for outside or whatever. Of course, I took that apart as well. You have to couple this tag with the tuning software of hearing aids. So there is some kind of authentication via a 7-character serial number. I doubt that there's actually a lot of encryption in there because the latency is crucial. Bluetooth already has a latency and you don't want to add that much to it. But I also tried to use a different tag with my hearing aids and it actually doesn't work, so some kind of authentication must be in there. But if you're too lazy to hack that, you can still hack the Bluetooth. There are like lots of talks about that here. And of course the pin is 000. And something that is not directly about the tag, but the hearing aids also communicate with each other. So if I switch the program, there's actually a small switch on my hearing aids. If I switch between the programs, on one ear it also tells that to the other ear. And that one doesn't use authentication. I have heard that when people have the same model of hearing aids and are close to each other, for example, it happens when couples buy the same hearing aids, then you switch your program and your spouse also gets the program switched. And this can actually only be changed by the audiologist by changing the channel. So they have like in for wireless, like different channels, and you set it to a different one. That's the security about that. Yeah, hacking. When I started to dig into that topic, I was really disappointed that there is not very much hacking. So there's one forum called hearingaidhacks.livejournal.com. This is the biggest one I found. And but if you go through the entries, it's mostly people asking for technical advice. So I bought this and this hearing aid. What peripheral hardware can I use with it? I guess the reason for that is that, I mean, the devices are really expensive and the warranty and yeah, the insurances are really not that nice if you break your own hearing aids, and you still have this problem that audiologists that have opening hours that cannot be used by people who still have a life. So people are a little resistant to actually hack the hearing aids. But there is a little hacking on the peripheral hardware. I will show some two examples for that. There's one guy called Gertlex who built his own Bluetooth adapter. He posted this on Flickr, quite detailed. And what you can see here, he used a Sony wireless Bluetooth headset and hacked it in a way that you can connect the direct audio input cables from the hearing aids. The picture here in the upper right corner shows the setup when he tested it. So he actually didn't test it with his original hearing aids. He used an old one that he had, and he even used an old MP3 player because he was afraid of frying that as well. So this is sort of the precaution that you have to do when you start, like frying your hearing aids. I mean, you cannot only fry your hearing aids, you can also fry your hearing even more, so you should be careful. And there's another guy who also made a Bluetooth adapter, he also took the DYI cables. Here are those shoes that you use to connect them, and a Bluetooth mono thing here. And this is actually the result that you connected directly to the hearing aids. He also provided some nice diagrams for that. The slightly bigger scene is actually the self-tuning scenes for hearing aid, because as I said, it's kind of frustrating to get hearing aids. You have to go to the audiologist a lot of times, and he asks you, yeah, what's wrong? And then you have to describe the situation. But you're sitting in this silent cabin at the audiologist, and so the adjustment is not really done in realistic circumstances. And a lot of people get frustrated about that. So they spend like weeks tuning the hearing aids at the audiologist, and still they're not happy with it. So they try to get the hardware and software that is necessary for it. And those are actually only sold to doctors and acousticians or audiologists. So, and they're not sold on eBay because it's medical equipment, and this is not supposed to be sold on eBay. So there you have to use other channels. There's like a black market for it. It's kind of hard to put a price on that, but I've seen like offers for the hardware, which is called Hipro, and there's different versions for serial USB or Bluetooth. And it starts with a couple of €100. So you can imagine the pain that people have when they already spend like 5,000 euros for 2 hearing aids, and then they spend even more money because they want to tune them themselves. And there is this self-tuner scene, and people really hack the system. So I've heard of people who actually installed a fake business, so they registered a business for an audiologist to buy this hardware and then stop the business again. So there are actually people doing a lot of effort to get this hardware and software. Of course, then you have no customer support, and when you fry your ears or your hearing aids, then it's your own fault. There's one exception. In America, there's a hearing aid manufacturer called America Hears. They sell quite low-budget hearing aids, up to $1,000, if I'm right. And you send an audiogram of yours, and they tune it at their place for the first time, and then you can like download the software and tune it a little bit more at home. Unfortunately, I've never seen that software. You can only order it in the US, but I would be interested to have a look at that as well, if someone has channels for that. Yeah, of course, some of this hardware ended up in my hands. This is a serial Hipro. So you have, this looks like really fancy, like a modem from the 80s. It's connected via serial. And you connect the hearing aids to it. I have some closer pictures for that. So you take out the battery and put on a small cable which has a contact of the battery, size of the battery, very flat cable, and this is connected to a bigger cable, and that is connected to the Hipro. The Hipro is the same for nearly all hearing aid brands, so you can use it for Siemens and Phonak and whatever. But these small flat cables, they are different for nearly every hearing aid. So if you try to buy this Hipro on the black market, you also have to buy those cables. There's also a Bluetooth version that also ended up in my hands. It looks like that and has the advantage that you're not connected to it by a cable, so you don't feel like on a leash. And I haven't really used that much, but this way you could actually go outside and tune it like in the subway or at your office, because you just need a laptop and that, and it works without your power for a while. Yeah, the tuning software, I showed you some excerpts from it. This is just another screenshot. On the right side here, you see the different programs. So the universal one, here's one for music and one for the tech, if you work on that, with that. When I was playing with the tuning software, I found something very interesting that is actually spying on me. So it logs some stuff. And for example, that how much I wear it. Although I find like 40 hours a day a little bit, I think I'm awake actually more longer than 14 hours. But they use it actually because people come and complain, yeah, this doesn't really work much, and then they see they only wear it like half an hour a day. And so, of course, you cannot get used to it and adapt to it. And you can also see what different programs I use. So mostly I use the Universal program, and sometimes I have another one called Universal that is it's actually tuned to have less feedback loops. That's the one I use when I put on a hat, so that I still hear a little bit, but don't have too many feedback loops. And it also tracks how often I was in a noisy environment or was listening to music. And since I like to listen to heavy metal, this is actually not correct. Yeah, I found it really interesting what you can see here, and yeah, I hope that it doesn't like record anything what I talk about or what I listen to. We have a little bit more time, so I will talk about cochlear implants as well. I mentioned that those are the ones that I have implanted in the head and also have an external device. This shows like you have, this part is implanted and you have a wire that is like drawn into the cochlear and it's connected to the nerve. So actually the whole ear is circumvented, only the wire goes directly to the nerve and then to the brain. And cochlear implants are what I find really fascinating. I mean, they really make deaf people hear. It's only applied to people who have a really severe hearing loss, like less than 20% or something. So they hear only less than 20%. Of course, it's a surgery to insert that. It destroys any remaining hearing because, I mean, you poke a wire into the nerve, so everything else is gone then. It can also affect other nerves. So I have a friend who had this surgery and they like touched some taste nerves as well, so everything tastes metallic. It was kind of weird, but it actually went away after a while. The signal is really different. The brain has to adjust to that very long. There are actually hearing courses after you get the surgery and the device is started. You have to really get used to that because, I mean, it's like electrical signals directly inserted. And the technology of these devices is usually behind the usual hearing aid technology because, I mean, it has to be like well tested before you put something into your head. And like for the other hearing aids, there are not many standards, no interoperability between the brands. So if you decide to take a cochlear implant of one brand, you can never switch to another one. So yeah, you have to think that through. I have an example of how it sounds with a cochlear implant. So it sounds kind of spooky. It starts with a normal sample that like everyone can hear it, and then they have like different channels and reduce the number of channels, and then it gets less and less hearable.
A boy fell from the window.
A boy fell from the window. A boy fell from the window. A boy fell from the window. A boy fell from the window. A boy fell from the window.
Yeah, so you can imagine that it takes a while until you actually can understand speech with that. Yeah, I'm coming to an end. So there are a lot of things that I want from the industry. First of all, better service. And that goes into the consideration of young people's needs, because you can feel that every time that everything is designed for the elderly, they don't consider that people actually have to work and have a life and actually want to go out and talk to people, and not only like in a silent room one-on-one. And there are a lot of things where you miss the support when you have hearing aids and are not 60 or something. Generally, I'd like to have better signal processing. Of course, regarding the size, they already did a really good job if you consider what they do already. But actually, the cocktail party problem is not solved. So a lot of people who have hearing aids and who also have really good hearing aids, they just avoid social situations. So they don't go out, they don't go to a congress, they don't go to parties. So whenever you would ask them to like go for dinner, they really carefully choose the restaurant if it's like a less crowded one, so you can understand people actually. What I'm really missing is some standards. I mean, it would be even cool if it was open standards, because this way you feel like really trapped as a patient. I mean, there's this saying like if you can't open it, you don't own it, and I really miss that when having hearing aids. So I have a lot of ideas how to improve that, but I don't see most of it coming in the next 500 years because of the companies are not very open source friendly. So what would be really cool to have something like a hearing aid app market that you can download the newest feature for background noise removal or something, and that you can like write your own filters and share those, and especially like exchange those between different brands. And the funny thing is, when I was browsing through the websites of the vendors, the marketing of some hearing aid companies actually got this idea already. They just call their features apps. So, I mean, it's just an enumeration of what the hearing aid can do, but they just call it apps. And I mean, it would be really cool if there was something like that. You can exchange those. And what I also like, I mean, hearing aids do not use like reoccurring situations. I mean, most people have a rather steady lifestyle. You live in the same apartment most of the time. You work in the same office. You take the same subway to work every day. And hearing aids are only tuned for like a general situation. But I think signal processing works well the more you have, the more you know about the surrounding. So it would be really cool if you have like one program for the office and one program for at home and one for the journey to the office. And I mean, we carry something around that knows all this. I mean, we have smartphones and they have a calendar and it shows where you are and it knows the people that you're talking to, and even like if you talk to them on the phone. So there could be like parameters for each person that you talk to, and that it could be saved on the smartphone if there wasn't enough space in the memory in the hearing aids themselves. So all the information is actually there, but I don't see any of the hearing aid vendors adapting to that. So, and what I also think, like, there are people like building 3D models of houses, and you could take this information into consideration as well. So if I have never been to the BCC, but someone has made a 3D model, you could also like calculate the characteristics of the acoustics here, and then you can, before you go to the Congress, you could download the acoustic settings for your hearing aids. That would be really cool. But, well, this is just ideas. Yeah, and then also regarding the hardware, it would be nice that there were some open standards. I mean, it would be cool if you could like print your own hearing aids with a 3D printer, at least the part that goes into your ear so that it fits really well. I mean, there are a lot of possibilities, but the market is really, really slow, and they still like try to figure out how do we connect Bluetooth, and yeah, for me it's just way too slow. I'd like to see like more progress in that. Yes, actually with that I would like to conclude, and I have to thank some people who helped me with this work, with the talk itself and all the stuff I talked about. And yeah, I think we have some minutes for questions.
Yeah, that's... Wonderful. So before we come to the questions, I need to say 3 things, which means please stay seated while the question and answers are going on. Then please pick up your trash and your water bottles and take them out with you. And then please leave through the front door here, while the last door over there is the entrance for the new people. So now we can go over to the question and answers. We have a signal angel again in the IRC setting and watching Twitter, and we have an audio angel in the back running around with a microphone. So please, questions now.
Hi, I have a question about the cochlear implantat. I'm a neuropsychologist, and I know that with eyes, there's an approach to kind of re-engineer the signal processing of the retina, and with this kind of knowledge you can make better retina implantats to enhance the possibilities of seeing with this kind of aid. And is there a similar approach for hearing aids and the cochlear implantat?
I mean, there are different types of cochlear implants, and I mean, this is really not much of my field of expertise. I know there are like those who still use the membrane in the ear, or some directly, the ones that I showed that directly insert the wire into the nerve. But I am not that familiar with the field, so I don't know what's coming there.
Okay, there's a question from the front row. I wonder, is there any connection of research in companies like Siemens or whoever builds these parts? Is that in any way connected with other consumer good research? Like, I'm not hearing disabled, but if somebody would come up with a decent set of in-ear headphones that would fit and would be able to do some noise cancellation or so, I'd be quite interested in spending money on that. But this seems to be totally uncorrelated altogether.
Yeah, that's true. I mean, it's pretty close to in-ear hearing, like headphones, but it's still, from what I've seen, a different market. I mean, you still can buy your new hearing aids if you don't really use them. I mean, no one can prevent you from that. But I don't see any trend in like merging that very much. Any more questions?
Hello. I would like to add two things to your wish list. One thing I would like the hacker community to find out what real differences in devices from different price ranges are. What is done in hardware and what is actually only firmware. My audiologist reported devices coming back from repairs or failed programming to report as more expensive devices, for instance, so it's just a firmware thing. And the other thing is I see an interesting hacking or attack angle thing for hacking in the protocol that the devices use to communicate with each other, or with the devices which transfer Bluetooth into the body area network that really speaks to the devices. So do you know any off-the-shelf components that can speak these body area network protocols?
For the Siemens thing I showed, I haven't found anything, so this is just that gadget that I have. But I think people are experimenting with the audio induction loops and the FM systems. Yeah, it's not that much that you can see documentation of that, so I'd like to see more here. I mean, I made this talk because I would tell you hackers what's on the menu, and it would be really nice if there was more activity in the scene, and it's kind of hard to start that if you're all alone. So I hope I've risen some interest, and if you have any pointers for me or anything I didn't mention here, so I'm also happy if you send me an email, or I will be around in the next couple of days. So, yeah.
Before we finish, there are some questions from the internet. The first one is Gilligan, who asked, does the fact that you have tinnitus make the process of tuning a hearing aid for you harder? Does a hearing aid have a negative or positive effect on your tinnitus when you wear it?
Of my what? Sorry. A positive or negative?
Does a hearing aid have a negative or a positive effect on your tinnitus when you wear it?
Actually, yeah, there are hearing aids that claim to counter-fight the tinnitus, that they like regenerate the counter frequencies against that. I also asked my acousticians or my audiologists about that. They actually don't work. I mean, they usually are not really offered, and even if you ask for it, they tell you, yeah, usually they don't really make a difference. My choice was actually just to make a normal hearing aid, and because the frequencies that you don't hear very well are amplified, the tinnitus in relation gets less loud, and you learn to ignore it. But that's not really magic, but that's the only thing that seems to work.
Okay, the next one is from Speckmade. Are there hearing aids with documented RP for the tuning official dog reverse engineer? Can you get the official tuning software to tune yourself? Did you write to any people who factor them?
I haven't found anything about that. The only thing you can do is like get the software on the black market and disassemble it if possible, but there are like no APIs or something. That's really, yeah, what I'm missing as well.
Okay, the last one is from Lucy, I guess. What frequency range can you usually hear using a cochlear implant? How fine can you resolve frequencies?
They are about the range that you have in the speech banana, but actually I'm not that familiar with cochlear implants, so I cannot give the details here.
Okay, hi. You showed us the programming tool for changing the settings on the hearing aids. I've forgotten the name, but the 1980s modem. Have there been any attempts to clone that hardware or reverse engineer the spec?
I'm not sure if I understood correctly. You mean like how you get the hardware for this?
Yes, so at the moment you have to buy the programming tool, as I understand, to update the software.
Since it's only delivered and sold by 2 audiologists and doctors, you have to be friends with audiologists or doctors, and somehow they can give you that, but there's no official channel, so you have to, find the black market.
Yeah, sorry, my question was, has anyone tried to create an open hardware variant? Has anyone copied?
No, I haven't found anything like that either, so that was actually also on my wish list, that makes the tuning hardware open source as well. That would be really nice. But I mean, it's a serial device, so you could actually do some sniffing there, but I haven't seen any approaches there.
Yeah, because it looks pretty easy, I would say. Yeah.
So we are running out of time. Is there any really, really important question left? You mean, because she's around, so you can meet her in the next days on the conference again, on the Congress again, and ask her more questions. And thank you very much for the talk. It was very interesting.